quick preview of what this journey has been. In August, these 16 today, but 19 total showed up. We're stuck on a team, and we're given a scope document that was 1 to 3 pages long and said, go do. They spent the fall trying to learn as much as they could, meet their stakeholder, build up their knowledge bank, and start to figure out what has worked and what hasn't worked in the field. That resulted in a mock-up that they built. The spring semester has been a lot of testing and breaking and rebuilding, resulting in the prototypes that you guys will see today, and that they have worked really hard on, and I think you can see the fruits of their labor really well. Today, this portion is going to be just a brief intro, just getting your appetite whetted. No questions at this point. Please write them down though, because afterwards there's going to be demonstrations and discussions in front of posters. Stay as long as you can, ask as many questions as you can. These guys really are experts on what they've designed, and I think that the more you talk to them, the more you'll see that. I'm really impressed with their growth, and I'm excited that they're going to get to share that with you guys today. So, with that, let's get going. The first group up today is going to be sharing a design for vertical tiger gates.
Hello everyone, good morning. My name is Emily and these are my teammates, Emmeline, Emerson, and Rush. For the last 9 months, we've been working together to create a standardized lion gate design for implementation at the Animal Park at the Conservators Center here in Burlington, North Carolina. Today, Emmeline and I are going to be introducing you to our project and walking you through some of our steps from ideation to our final prototype. As I mentioned, we had the pleasure of working with the Animal Park at the Conservators Center, which is home to over 70 animals of many different species, including a tortoise, foxes, wild dogs, wolves, tigers, and of course, lions. Their mission is to give these animals the best possible quality of life while educating the public on wildlife conservation. One reason why they were open to collaborating with Elon students is that there's a lack of interest from the engineering field in animal enclosures. So there aren't a lot of current designs on the market for nonprofits such as the Animal Park to go off of when creating their gates. The expectation from the Animal Park is that we were to create a standardized and scalable gate design. So this design needed to be able to be made larger or smaller depending on the enclosure size and the species. It also needed to operate the same at every gate across the park. It needed to be equipped with a locking mechanism and an emergency close system, as well as, of course, be able to withstand the force of a lion. Our deliverables for this project were to create a full-scale steel prototype and an engineering design packet that is equipped with anything that a fabrication shop needs to reproduce this model, and anything that the Animal Park needs to know how to operate and service these gates. As you can imagine, after hearing about this project, we're very eager to get down to the Animal Park and see these gates in action, and of course meet some animals. The pic on the left here is one of their current vertical gates in the open position. The first thing that stood out to us at the Animal Park is that all of these gates are a little bit different, but despite this, they generally operate the same way by unclipping a cable from the chain link to lower the gate, and then a pin has to be engaged from the access point all the way through to the gate door to ensure that the lions can't open the gate or lift it. While this process seems simple, depending on the gate, some of these steps are more difficult than others. One of the main difficulties is the force required to lift these gates, which is due to inefficient pulley systems at the Animal Park. Additionally, across the park, the pins vary in length, so while some enclosures have pins that are a couple inches and very easy to engage, others are a couple feet, so it can feel like threading a needle to get that pin in place. While the Animal Park is confident in the safety and functionality of their current gates, based on the variation across the park, it indicated to us that there was room for improvement in the design to make the operation process more streamlined and easier.
After having the opportunity to visit the Animal Park in person, we began our ideation phase. So we did extensive research and a lot of brainstorming to find solutions to the inconveniences that the staff was currently facing. You can see a few of our initial designs that we had drawings of right here. We decided to split our design into 4 main subsystems, including a gate and frame, a spring locking system that replaces the various pin links that they have, a winch to crank the gate up and down and have one point of operation, and a pulley system that will reduce the weight of the gate. After making our final decisions on our materials, we began building a wooden mock-up of our prototype. So we integrated all of our subsystems and performed testing to see how they all work together. We also created CAD and SolidWorks of both our wooden mock-up, which is on the left, and our final prototype that's on the right, and that can be used by manufacturers in the future if our design is pursued. After ordering our final materials, we began our manufacturing process of our final prototype in the manufacturing shop we have here at Elon. We made small adjustments to the materials we had already ordered, such as increasing a winch diameter, and we designed and manufactured some parts, including our spring lock. The picture on the right was a huge moment for our team when we stood up our working prototype for the very first time, standing at 10 feet tall. A few staff from the park had the opportunity to come and work our gate. They were very impressed with the design features that we had incorporated and the ease of use. The three main design aspects that improve the operation process is the spring lock that's operated by a cable any distance away from the gate to disengage the pin, and it replaces the long pins that they currently have. We also have a winch that is located at the same point of operation as the spring lock to accommodate for any gate geometries that they have currently. We also have a pulley system that reduces the weight of the gate to a third of what it originally is. With the combination of these design features, the gate requires significantly less force to operate than what they currently have. We also incorporated an emergency closing system where a lever is flipped on the winch and releases the gate down into a closing position in case of any emergency situations. Building this gate was an incredible experience for our team. We're so grateful for our stakeholders, Mindy Stinner, Dr. Epting, and Megan Millard, and also to the faculty here at Elon who advised us through the entire process. Thank you so much for listening, and we can't wait to tell you more outside.
Okay. Good morning, everyone. My name is Lauren. This is one of my teammates, Zoe, and our other two teammates, Allie and Kevin, couldn't make it here today, but I'll be speaking on behalf of our team. So we worked alongside the vertical gate group. We are the horizontal gate group. Today I'm going to walk you through our different challenges, restraints, and our overall design process. So we also had the opportunity to visit the animal park and see their current setup. Their current horizontal gates have different restraints considering that we don't have the assist of gravity like the vertical gate does. And their current setup is a simple push-pull gate with a very large handle. Like the vertical gate group mentioned, all of their locking mechanisms are a little bit different. An example of that is on the screen. And their gates are connected to wheels that move inside of a unistrut, which is a square-shaped channel that acts as a track for the wheels. The expectations from the animal park for our team was to create a standardized gate system, a secondary locking mechanism, and since there is no emergency close situation, we were asked to create an emergency close system. Our design process started up with us deciding to use a boat winch to operate the gate and crank it open and close depending on the direction that you crank the winch. You can see the beginning of our design stage and along with our wooden mock-up. This wooden mock-up is to support and imitate the current chain link fences that are found at the park, and this mock-up gave us a good idea of what our gate and our winch would operate like. This led us to our final gate prototype. We used a unistrut similar to the animal park already has, with cable and wheels running along inside of it. The cables then wind up in the winch, the boat winch, and as you can see, the winch is would be a few feet from the animal enclosure to give a little extra space between the volunteers and the animals. There will also be a pulley on the other side to hold all the cables upright, along with connecting the emergency close to the gate. This is a final CAD drawing of our gate just to help you guys visualize what the gate would look like implemented into the chain link fence. The emergency close was our biggest challenge for my team and I. Like I mentioned before, the vertical gate group had the assist of gravity, unlike the horizontal gate group. So we went through a lot of different ideas of how to make this work, and these were the top ideas that we had that didn't necessarily make the cut. One of them being a sandbag that would be connected to the gate on a shelf that would then drop. This idea had a major drawback considering that there was a lot of friction. Another main idea that we had was a shelf with a sandbag with ball bearings that would then slide out from under it, dropping the sandbag. Due to weathering and rusting, this made this option not very reliable. Through a lot of trial and error, this led us to our final emergency close, which is a simple tipping bucket idea. The bucket would be on a platform a step away from the winch. So it would be filled to the brim with cement, rebar, and cable connecting it to the gate. So a volunteer would take a big step, push the bucket over, and it would slam the gate closed. Some of the volunteers from the animal park came and got to test our winch and our emergency close, and they were very pleased with the idea. They loved how it was fail-safe, easily replaceable, affordable, and all the materials could be found very easily. They also loved the intuitive idea of it. Since this bucket would be filled to the brim with cement, it would be weighing about 100 to 150 pounds. But we added a tilt to the bucket to decrease the weight to about 2 to 5 pounds. The final deliverables for our project would be CAD mock-ups or CAD models for any alterations to the subsystems that would be necessary, and a design packet to walk the Conservator Center through any of our thought process and a step-by-step instructions of how to actually construct the gate. Thank you so much to the Animal Park for helping us and guiding us along the way, along with the engineering department with all their advice and guidance. We had so much fun working on this project, and thank you so much for your time.
Good morning, everyone. My name is Tyler McKellar, and I've had the honor to work with Nadia and Skylar on our project of erosion and stormwater management at the Christ Mount Retreat Center. Starting off, Christ Mount is located in Black Mountain, North Carolina. They are a non-profit organization that has programs centered around spiritual, educational, and community-based programs. They have a big and natural campus, which is why we have this problem of erosion due to the intense rainfall and other natural disasters. As you can see in the image, since Christ Mount is a pretty big place, we decided to focus our expertise into one specific area, pretty much getting the problem at one source instead of kind of focusing everywhere. One example I can say about the erosion is due to Hurricane Helene that happened a couple months ago. On the left is a picture of one of the trails that they have, but on the right is the unfortunate disasters that happened. The erosion and the heavy rainfall cut into the paths, making it unsafe, environmentally and just safety factors for transportation. They had certain solutions prior, but that didn't seem to withstand the intense rainfall, so that's where we come in with our solutions. We decided to have, instead of just one solution, 3 solutions that work all together into one complex system. Each will be discussed later on in the presentation, but we have a French drain, a retaining wall, and a riparian buffer. Starting off with the French drain, we calculated that it would need to be around 225 feet long with a perforated pipe that would be in ground. Unlike other groups, we actually, our tests and our prototypes are pretty much our calculations, our numbers. So we had to run a lot of numbers, which is why we got around, the diameter of the pipe would be around 6 to 10 inches. It's a range to show that it's not too small to where the rainfall, the intense rainfall could overwhelm, pretty much overflow the pipe, and we didn't want it to be too big to where it would just be in excess of space taken up. Next is the retaining wall, and the retaining wall would be within the stream. The reason we have a retaining wall is to take any of the forces, either from the soil pressure or the water pressure, or any other surcharge loads that the original stream creates. The original problem is that with the intense rainfall, or just rainfall in general, it rushes and it hits the side of the stream, which creates the erosion on the stream, and it kind of takes away all the soil, any type of nutrients within the soil, affecting the plants around it as well. So the retaining wall prevents all the problems of taking away soil, affecting the groundwater, and then affecting vegetation that they have on at the retreat center as well. The retaining wall would be built with concrete reinforced with rebar to make sure it's sturdy and durable for not only just one, pretty much Hurricane Helene, but hopefully not a lot, but any others in the future. The last part is a riparian buffer. The riparian buffer is pretty much a basin or a bowl that just collects all the water from the French drain. It'll be at the end of the French drain and on the side of the stream as well. The purpose of having both the French drain and the riparian buffer is to avoid any excess stormwater from going into the stream, which would increase the stream, meaning it increases the forces and the pressure, which would cause more erosion. So we're trying to get it from the source, and having all these steps than just having one solution and have to worry about other steps in the process. We wanted to keep it more natural, or as natural as we possibly can. So we have other natural shrubs, plants, and ferns around it. So it can also increase or better the biodiversity in the area, and just give back to the soil that is already there. We currently have, as you saw in some of the images, computer-aided design or CAD drawings that we've made to show the ideas that we have. We have a whole package, and we'll have have a full bid package, including our cost sheet for Christmount. Next steps will be giving it to Christmount so they're able to fact check everything the best that they can and give it to their own engineers and technicians. We also showed that we gave them around an estimate of how long it would take to build everything in total. And we know that since Christmount focuses on volunteering, we estimated they can have their own volunteering group to build everything from themselves. Knowing that we have a lot of materials that could be built from scratch without having big machines or big engineering companies to take part of this process as well. Last thing I would like to say is that I know that we have all three of us were very grateful for this project. We were able to have a real world problem and create solutions that we know would impact positively for Christmount and the people around Christmount. We'd like to thank Christmount for allowing us to have this, to work with them in this issue to the best of our abilities. We'd like to also thank Rob Morris, who is the executive director of Christmount, who has shined light on to help us in the process, especially after Hurricane Helene, because that was a very interesting time. I'd like to thank our mentors, Dr. Kluwer, Dr. Brinkman, and Mr. Ring for teaching us and helping us learn through this entire process. And then, of course, thanking the entire Elon Engineering Department. Thank you.
Hi, everyone. So I'm Lily, and these are my teammates, Gloria, Braden, and Tim. And we made a window panel for people with mobility problems. So to start off, I want everyone to think about the first time they drove. You gained freedom, dignity, probably even bragging rights among your friends. Most importantly, you finally had the ability to live life on your own terms. For people with mobility limitations, this freedom means so much more, but it's also much harder to find because cars generally aren't designed with them in mind. This leaves them dependent on others to get around, so gaining access to a vehicle can be life-changing, giving them the chance to finally be self-independent. Cindy Crompton realized this was a problem and realized she could help. She started her company, Driver Rehabilitation Services, and since then has traveled all over North Carolina, bringing people the tools and skills they need to drive independently. Throughout the years of doing this, Cindy's noticed some issues with some of the more common modifications. One of the big ones is the window panel that allows you to open and close the windows. Because of its shape, it's nearly impossible for most people to use it with a mobility problem, and the current solution, gluing posts or sticks on top of it, tends to fall off and is one of the most frequent repairs she's making. On top of it being so temporary, in Cindy's words, it's also very ugly. She came to us to help her design a more permanent and aesthetically pleasing solution to make a window panel accessible. Throughout the process of designing this panel, we went through many stages of brainstorming and revising, but we ended up landing on what we think is the best long-term solution. From day zero of this project, before we were even supposed to start brainstorming, we got to talk to some of Cindy's clients, including Hank, who's in the audience, and get their opinions on the design, from the shape to their color preferences. We also got to test drive some of the cars, which allowed us to empathize with the struggles of the users. Finally, we got to talk to technicians who will be installing this. We got to hear what they find easiest to install and also what seems to work the best. Using this information, we were able to come up with what we think is the best long-term solution: permanent replacement pieces, which my teammate Gloria is going to come and tell you more about now.
This is our final prototype. The banner replacement pieces were designed in CAD and 3D printed using ABS plastic. These new pieces are designed to fully replace the existing ones on the window panels. It's been a journey to get to this point. We went through several rounds of design tweaks based on real-world testing, checking temperature endurance, adjusting the shape of barrier ergonomics, and improving the structure to withhold forces. Comfort was a major factor, but we also had to make sure the design was not only sturdy, but just functional and resilient over time. During testing, we measured the temperature on the range from 10 Fahrenheit up to 150. We also ran some testing based on real work forces, and we achieved up to 22 pounds of force. This main test included were temperature endurance and mechanical strength over repeated use. Each small adjustment brought us closer to a design that is not only functional and user-friendly, but durable enough for long-term use. This project has been truly one of the most fulfilling experiences for all of us. We got the chance to design, test, and think like engineers, and most importantly, work as a team. Working with our stakeholders has shown us how efforts can truly change someone's life. This has been the most rewarding part of our project. We're so grateful to Cindy, her clients, our stakeholders for allowing us to be part of their family and giving us this opportunity. Thank you so much.
Hello everyone. My name is Sasha, and this is Jack and Jake, and we also have another teammate who graduated early in December. We got the opportunity over the last 2 semesters to work on designing and building an electric boat. We got to work with the American Society of Naval Engineers, and we also got the opportunity to compete in a competition during April called PEP, which stands for Promoting Electric Propulsion. For this project, we were given a scope, which required us to design a remote-controlled unmanned vessel that's 4 to 8 feet in length. We also were given a documented list of rules for the competition, which required us to integrate a kill switch and a fuse into our system. For a race day, we were required to run a 2-mile course, and we also had to carry a 30-pound payload. We were also given rules for our voltage system, which required us to run a voltage system that was under 55 volts, and we couldn't exceed 500 amp hours. For our design, we broke it up into 3 different subsystems. Our first subsystem included our hull design. Our second subsystem included our battery box, which included all of our voltage system, and our third subsystem included our propulsion and steering system. So starting off with our hull, we used 12-gauge 5052 aluminum series, and we designed our hull in SolidWorks using the sheet metal tool. We were able to send our design to SendCutSend to have it laser cut. We received our shipment of our hull in 7 different pieces, and we were able to TIG weld it together in the shop here. Moving on to our battery box and our cooling loop. We used 12-volt LiPo batteries to create a high voltage system and a low voltage system. For our high voltage system, we used 8 different batteries to power our propeller and our rudder. We also used a low voltage system, which only included 1 battery, that powered our self-priming pump, which brought in water from an outside source, running water around our batteries within our battery box through copper brake tubing, and expelled water out the side of the boat. Finally, for our propulsion and steering system, we designed a mounting system that was 3D printed. This allowed us to make a modular design that was easy to make alterations to throughout the design process. This also included our propulsion, which we used a 3-bladed propeller for, which was powered by a FlipSky brushless motor and speed controller. For our steering, we used a linkage mechanism to rotate our rudder, which was powered by a 35-kilogram servo. Throughout this whole process, we conducted many tests to simulate race day conditions, One of the tests that we ran was a cooling loop test, and we ran our batteries inside of our battery box for an hour using our cooling loop and without using our cooling loop. As you can see on the graph on the top, you can see that our temperature inside the battery box rose about 10 degrees Fahrenheit, when we use our cooling loop in the bottom graph, you can tell that we maintained a steady temperature throughout the whole hour we ran our batteries. We also ran a max range test to test the max range between our controller and our receiver, which we determined to be about 1,500 feet. We also ran a max speed test, which we determined to be about 3.5 miles per hour. On competition day, we were able to qualify on the first day in harsh and windy conditions, which allowed us to compete on the second day of the competition and finish a 2-mile course in 39 minutes and 11 seconds. This put us in 11th place out of 30 uncrewed teams. We were very pleased with our results as a first-time team competing at the competition. We are so grateful for this opportunity, and we had a lot of fun working on this project. And we would like to thank our stakeholder, Mr. Michael Briscoe from the American Society of Naval Engineers. And we would also like to thank all the faculty and advisors from the Elon Engineering Department. Thank you so much.
Thank you all. That is the end of our presentations. I do want to give one shout out to the students. This is a lot of fun. In the fall, it's really stressful to watch and hope that you guys are going to turn out, that your designs are going to work, that you're going to make us look like we actually taught you guys engineering. And you came through, and it makes our job really fun and valuable. And we can't wait to see where you guys go with these designs and then after graduation. So big round of applause for all of us.